Hello, statistics. So today we are going to start the packet. And if you get that out now, you're going to want to be able to hit pause when we get to the definitions. So we're going to take a look at a page at a time here. So first off, we are going to look at some vocabulary. So let me press the button here so we can get going. All right. So on page 1, we are about to talk about the second type of statistical inference that we're about to learn. The first type was confidence intervals. So this chapter starts something new. It's called hypothesis testing. So we're going to start with some vocabulary. So you might want to hit pause right now so you could copy this. All right, so we have used this term quite a bit. Statistically significant, we know, means that when something is unlikely to happen by chance, or it's unlikely to occur as the result of just sampling variability alone. The next vocabulary word that we're going to talk about is hypothesis test, and it is a test that we use to see if our sample results are statistically significant. So there's two types of tests that we do when we talk about hypothesis tests. One is called the null hypothesis. The other is called the alternative. You might have heard the AP Stats guy call them the ho-ha. So the ho up on the top is the null hypothesis. So what can we say about the null hypothesis? It's often called the dull hypothesis. And this is the one that we say about our population parameter, and it's always a statement of equality. So we're going to assume that something is true, and that's how we're going to set up our hypothesis test. So it's what we are checking the strength of our evidence against. So one thing that you do want to know about the null hypothesis is we never say we accept it. We either say that we reject the null or we fail to reject the null. You can see if you take a look at this diagram here that when our results are greater than 2 standard deviations away, which we know would be in that 5% category, then we would find that highly unusual. So we would reject the null and then we would accept our alternative hypothesis, or we would fail to reject the null because it's not something that doesn't seem unusual. So here's another way to look at that. So if we got a value more in the middle here, that would not be very odd, and we would say be perfectly compatible with what we are stating our null hypothesis is. But when we take a sample and if we get a value that's out here with our z-values, something greater than 2, that's when we say that, yeah, this seems a little bit weird, so we would reject the null. All right, so the alternative hypothesis is also a hypothesis about the population parameter. It is what we are checking the strength of our evidence for. So if we reject the null, then this is the statement that we normally say is true. So it's the null versus the alternative, or the ho versus the ha. All right, so just another way to say a couple things here. So the two hypotheses are called the null hypotheses. They say H naught, that's what the little zero is, or the other one is HA, sometimes H1. That's called the alternative hypothesis. Okay, when we take a look at these hypotheses, you notice that the null hypothesis always is said with an equality statement. There's going to be different types of hypotheses tests. We're going to have a one-tail test. You could see we have a lower tail on the left and upper tail on the right, or we could have a two-tailed test, and that's when we say that it is not equal to. The other way is when we say that it is either greater than or less than for the alternative hypothesis. All right, so if we reject the null, here's a picture to think about when we reject the null. Look at the area in these dark tails here. We're concluding that we do have enough evidence from our sample to infer that the alternative hypothesis is true. If we don't reject the null, that's because we get a value somewhere here in the middle, and it's not just statistically significant enough to infer that our alternative hypothesis is true. So you should have learned yesterday that when we talk about hypothesis testing, it's a lot like trial by a jury. So you're probably going to want to put the machine on pause here to copy this down. All right, so we're going to take a look at this a little bit. So our alternative, our null hypothesis is that our defendant is innocent. So the defense is going to present the null hypothesis. It's like the defense saying, hey, my guy's innocent. If we provided some sort of statistic, that says, you know, I think that this is true, that the true value is that 75% of people wear their seatbelt. The prosecutor's job is to present the alternative hypothesis because they believe that there's a different truth that's happening other than what we're saying for the null hypothesis, other than what that's claiming. So the prosecutor is trying to show guilt. So the alternative hypothesis might be something like, no, no, definitely when I collected my sample, I see more than 75% of the people wear their seatbelt. All right, so it's our prosecutor's job to provide the evidence to show the judge that the null is false. So once again, that's going to happen with our sample that we collect, and we're going to look at the statistic, and we're going to look at the z-value. And the evidence is this sample statistic that we provide. So it's the judge's decision, once they look at the evidence, to decide if it's strong enough to say if the null hypothesis is wrong, and then we reject it, or if the evidence doesn't show anything out of the contrary, and then we fail to reject the null hypothesis. So the null hypothesis is when we claim innocence, nothing is happening. The alternative hypothesis is when we're trying to prove that something other than the null is going on. All right, so let's take a look at one of these right here. So the large cities Department of Motor Vehicles claim that 80% of candidates pass driving tests, but a newspaper reporter's survey of 90 randomly selected local teens who's taken the test only found 61 who passed. Does this finding suggest that the passing rate is lower for teens than the DMV reported? So we need to write our two hypotheses to start with. So remember, the null hypothesis is going to be a statement that we have a probability equal to something. So when you take a look at this, we are going to say that, well, our null hypothesis says that 80% are going to pass the test. So we're going to say that the null hypothesis is that P equals 80%. When you read a little bit closer, we want to know, is the rate actually lower for teens? So that's why we're going to set our alternative hypothesis as less than 80%. Okay, now we go through the conditions that we went through all last week. We have to assume independence, that when we sample these values, that the way one answers won't have any effect on the other one. Then we're going to have to talk about these three conditions. So take a minute and write down what you think they will be. Pause the machine. Okay, check out your random sampling condition. How did you do with that? Must be a good representative of the population. It must be a simple random sample. All right, check and see how you did on the next condition. Once again, remember, for success and failures, we have to have a large enough sample size so that we have at least 10 successes and 10 failures. You test them out, you can see that that's true. And then finally, the 10% condition. Remember, our sample can't be any larger than 10% of the population. And it seems reasonable to think that there are more than 900 teens that attempt the DMV test. All right, so now it's time to actually do the mathematics. So we're going to try and get the z-score here. So if you recall, the first thing we need to figure out is our sample statistic. So they said 61 out of 90 passed the DMV test, so we could do that. All right, then we're going to calculate the standard deviation for that. So we do our square root of 0.80 times 0.20 over 90. This is what we're expecting. And then we calculate the z-score. So we take the sample statistic, the 0.678 that we calculated from our sample. We subtract the true proportion that we think it is, which is 80%, and we divide by the standard deviation, and we get a z-score of a negative 2.90. So now it's time for us to state our conclusion. What do we think now that we see the z-score? Do we believe the null? Should we reject the null? Or should we fail to reject the null? So because 0.678 is more than 2 standard deviations below 0.80, the results are statistically significant. So we're going to reject the null hypothesis. And we are going to go with our alternative hypothesis that states that less than 80%. All right, so I'm going to try this one on your own right here. Take a minute to read this about Major League Baseball teams. We want to know if they have a home field advantage. In 2007, Major League Baseball teams, there were 2,431 regular season games. Turns out that the home team won 13-19 out of the 24-31, or 54.26%. So we want to know, is this deviation from 50% just natural sampling variability, Or is it evidence that this team actually has a home field advantage? So we need to start by writing our hypotheses. So write down what you think the null hypothesis is. Remember, this is a statement of equality. And then what do you think our alternative hypothesis is? All right, how'd you do? The null hypothesis is that there is no home field advantage. The probability that the home team's going to win is 0.50. The alternative is that there is an advantage, so it's greater than 0.50. All right, now you have to go about and you have to think about checking your conditions. So take a look and see if you checked your conditions. All right, and finally, we're going to do the mechanics. We're going to calculate the z-score. So the first thing we do is we calculate our sample statistic. It's 0.5426. Then we calculate the standard deviation based off of that sample statistic. Turns out to be about 1%. Then we calculate the z-score. So we take our sample statistic and we subtract our sample proportion and we divide by the standard deviation and we get a z-score of 4.20. So because 0.5426 is more than 2 standard deviations from 0.50, this is statistically significant and we reject the null hypothesis. So we do have evidence that suggests that there is a home field advantage. The probability of winning is greater than 50%. All right, I hope that helps and I will see you tomorrow.